Welcome to Elk River Math Lab. The topic of this video is for Exponential Algebra, Section 8.2b. How do we factor a common monomial out of a polynomial? Let's begin. In this section, we're going to be factoring a monomial out of a polynomial. Before we get to an example, though, we need to remember a couple things about division. First of all, a negative divided by a negative is a positive. If we only see one negative and one positive, then the division will result in a negative quotient. Also, when we divide and we have common bases, like x to the 7th divided by or over x to the 4th, we subtract the exponents and we'd get x to the 7 minus 4 or x cubed. Now we're ready to undo what we did in the last section where we were multiplying a monomial in, and we used the distributive property and hopped it in or multiplied it into every term. Now we're going to reverse that process and divide it out. Okay, by it I mean what goes into both of these terms in this polynomial. So if your prompt was factor this polynomial, it means break it apart. Factor 6, 3 times 2. So factoring means break into multiplication. To do that, I need to divide, and I need to ask myself 3 questions. First of all, that d, make sure you put a 1 on there. Make sure you know the answer to what's the exponent on the d. Secondly, we're going to ask ourselves, what number goes evenly into 6 and 21? I like to grab that smaller one, 6, and say, does that divide into 21? If I'm not sure, I use my calculator, but the answer is no. Then I go to the next biggest factor of 6, which is 3. Does 3 go into 21? Yes. So I know I can divide a 3 out of both of those coefficients or both of those lead numbers in each term. But then I see c's in both of them, and I say, well, how many can they each afford to give me? Well, the second term only has 2. So when I'm going to be dividing them out, I grab the smaller exponent because that's all the second term can afford to give me with those c's. Also, d's are in both, but that first term only has 1. So they can each afford to give me a 1 at most. So we grab the smaller exponent. So notice I'm going to be pulling out a 3 as the number, 2 c's, and 1 d. So we're going to divide out or hop out a 3 c squared d to the first. And you can picture dividing each term by that monomial. And we're going to hop it out or undo what we did when we multiplied. So here's what I'm hopping out, or my common monomial. I have to decide what I put back in the parentheses. So we go up to the top and we start dividing. 6 divided by 3 is positive 2. C to the 5th divided by c squared, I subtract those exponents. So I get c to the 5 minus 2, or c to the 3rd. The d's, I only have 1 on the top and 1 on the bottom, so they completely cancel. Or you can think d to the 0, which is 1. Basically, I don't need any more d's. Now for my sign, I have a positive 3, but I need to get a negative 21, so I need to have a negative sign here. 21 divided by 3 is 7. So picture just 21 and 3. We're taking a 3 out of 21. I'm also taking 2 c's out of 2 c's. They're going to completely cancel. Or you can think c to the 0, which is 1. But I don't have any c's left when these cancel. And how about the d's? I have d to the 7th over d to the 1st. 7 minus 1 is 6. Or you can picture that 1 on the bottom canceling out 1 on the top. And this now is the factored version of the original polynomial. So let's remove that division up above. That was the original problem, and we just said this is our answer. How can we check it? Do what we did yesterday. Hop or distribute your 3c squared d in, and you'll get 6 c to the 5th d minus, next hop, 21 c squared d to the 7th, and it checks out. So that's the end of 8.2b.